In this short video, we are going to see how to configure a peripheral module with the data transfer controller DTC. The data transfer controller is a specialized module in the microcontroller which can transfer data without CPU intervention from a user-specified source to a user-specified destination when an interrupt occurs. The source or destination can be a peripheral or a memory address. This also means we can transfer data when the CPU is in a low power or sleep mode. As usual, we start by initiating a Renesas RA project. We name it My DTC. Select our RA6 M4 board and maintain the default settings for the rest. Then we select the bare metal template. The peripheral module that we are going to configure is the UART communication module. So we start by adding the UART stack from the Stacks tab and Connectivity menu. We will configure the UART stack first. We will use channel 4 for our communications. And then we need to initialize the port for UART communications. In the operation mode, we select the asynchronous UART. This will initialize pin 206 and 207. Now, coming back to our stacks, we can add the DTC driver from the stack view. In order to use the DTC transfer, we have to go to the properties of the UART module and enable DTC support. Now, we can generate the project contents to start our coding. The code is similar to writing for an UART communication. We will first initialize the status variable. And then we can take help from the Developer Assistance menu to write our codes. We will first open the UART channel. Next to the code block for opening the UART channel, we will insert the assert macro. It checks the value of an expression, and in this case, the success status of the UART open function must be returned for the program to proceed. The status variable may also return any of the proprietary error codes of FSP. And then we will initialize the variable that stores our data. We will then create a while loop to send our text message. We will edit the arguments of the write function to point to our data. And we will add a small delay after our text transmission. We can now build our project and debug. The project has been built without any errors or warnings. And we can try to upload the program. Once we have uploaded our program, we can now connect the EK board to our computer using a TTL to USB adapter. We can use any generic USB to TTL adapter. For this demo, we are using the CP2102 model adapter. For this adapter module, we need to connect the TX pin of the EK board to the RX pin of the adapter and vice versa. In the terminal, we set up the new connection to receive data through this USB, and we set the proper baud rate for the serial port. The serial port settings in the teraterm terminal should be same as the configured UART channel in the FSP. This can be found in the Properties section of the stack. Once we have completed the settings, the connection is established and the text is sent from our board to the computer via the UART channel supported by DTC.